We are living through the fastest energy transition in human history.
But beneath every battery lies a deeper extraction.
Lithium, the white gold of the clean revolution.
The demand for minerals is reshaping landscapes at unprecedented scale.
Raw earth becomes the core of our clean machines. Above ground, it looks clean and silent.
Demand is not linear. It is accelerating. An electric vehicle requires far more minerals than a petrol car.
Copper is the bloodstream of electrification. This is not local, it is global.
Behind every advanced battery lies a global chain of labor, logistics, and livelihoods.
Before powering a clean future, minerals pass through energy-hungry factories.
Clean energy can still leave scars on fragile ecosystems.
Extraction leaves behind mountains of waste.
In arid regions, water resources are carefully monitored as industries and communities share limited supplies.
Minerals are becoming instruments of geopolitical influence.
As demand grows, scientists and policymakers are studying the mineral resources resting on the ocean floor.
Transforming raw materials into advanced components requires significant energy input.
Every glowing screen is part of this chain.
The minerals we need, at what cost?
The next mineral deposit may already be in our homes, waiting to be recycled.
Advanced recycling technologies can recover valuable materials again and again.
Researchers are exploring chemistries that rely on more abundant materials.
Sometimes the most powerful solution is not extracting more content, but needing less.
Stronger standards and cooperation can shape how minerals are sourced. Responsible extraction also includes restoration.
A circular system could reduce the pressure on new extraction.
The mineral transition is not just technological, it is global. Speed matters, but so does stewardship.
The materials that power modern technology are part of a complex global story. How we manage them will help shape the world ahead.
As demand rises, supply chains must remain stable and transparent.
Mineral markets can be volatile, shaping investment and policy decisions.
Many nations are investing in refining capacity closer to home.
New technologies aim to improve efficiency and safety in extraction processes.
Researchers are searching for substitutes that ease pressure on scarce minerals.
Strategic planning can buffer against sudden disruptions.
A new generation of engineers will shape how resources are used. Transparent dialogue can build trust between communities and industry.
Energy and materials must be planned together, not in isolation.
The choices made today will echo far beyond our own generation.
Minerals, energy, and infrastructure are increasingly part of one connected system.
Resilient systems are designed to adapt to uncertainty. Technologies, once experimental, are now reaching industrial scale.
Transparent data can help guide responsible decisions.
Long-term planning includes care for the landscapes that support us.
The next chapter will be written by those building solutions today. The materials we depend on are drawn from a single, shared planet. Progress is possible when urgency and responsibility move together.
Transformation often happens gradually for Mower, but its impact can be lasting.
The story of minerals is ultimately a story about how we choose to live within our limits.
Better data can improve how resources are planned and managed.
Governance continues to adapt as technology advances.
Diversified supply chains can reduce systemic risk.
Measuring the full life cycle of materials can guide better decisions.
When planned carefully, projects can contribute to local development.
Incremental improvements can add up over time.
Research does not end, it evolves with each new insight.
Scale reminds us that progress must remain in balance with the world that sustains it.
Transformation can be steady, deliberate, and enduring.
The mineral transition is part of a broader journey to Plutus, one that continues beyond any single generation.
When supply is concentrated, materials can quickly become strategic priorities.
Small delays at key choke points can ripple across entire industries.
Some countries are investing in processing capacity to reduce dependence on long supply chains.
Partnerships can increase transparency and reduce competition for limited supplies.
Traceability tools are improving visibility across complex supply chains. Resilience is not assumed. It is designed and tested.
Recycling can act like a new supply source, closer, cleaner, and more predictable.
Shared standards can raise the floor for environmental and social performance.
With the right guardrails, industrial activity can be managed more responsibly. And just as solutions appear, new pressures begin to form.
Before decisions are made, the ocean floor must first be understood.
Experts continue to assess potential benefits and risks.
Some policymakers advocate a precautionary pause while research continues.
Others argue that climate timelines require secure access to key materials.
Some propose limited, closely monitored trials to gather more evidence.
Monitoring systems aim to provide transparency and early warning signals. No single solution carries the transition alone. Progress depends on many working together.
The choices surrounding minerals reflect how we manage shared planetary resources.
The mineral transition is not a single decision tree, but an ongoing process of balance, evidence, and adaptation.
The systems we build today become the inheritance of tomorrow.
Minerals are abundant in some places, but not infinite everywhere.
Over time, markets often adjust as supply expands and demand becomes clearer.
The transition involves governments, industries, and individuals alike. Energy systems are built not for years, but for generations. Every pathway carries trade-offs. The challenge lies in managing them wisely.
Innovation rarely stops at a single breakthrough.
When systems align, pressure can ease without compromising ambition.
The transition is as much about stewardship as it is about supply.
Progress may not be perfect, but it can be thoughtful, steady, and grounded in evidence.
Transitions rarely move in straight lines. They improve through adaptation.
Each generation refines the systems it inherits.
The resources we depend on come from one shared world. Sustainable progress depends on balance, not extremes. With planning and evidence, complex systems can become reliable.
The story of minerals is evolving from extraction alone toward intention.
Lasting decisions are strongest when grounded in evidence.
Ambition matters, but so do limits. The minerals we need are real. The path we choose is ours.
The minerals we need are part of a larger story about balance, evidence, responsibility, and the world we leave behind.
After the headlines fade, the systems remain. The mineral economy is not a single line acceptless, but a web of interconnections.
Forecasts can guide us, but uncertainty always remains.
Technical solutions often raise ethical questions.
Resilient systems learn and adapt over time.
Understanding complexity is part of responsible participation.
Shared standards can strengthen trust in complex supply chains. Progress is often incremental to how, and always evolving.
The mineral question is ultimately about how we live within a finite world.
The minerals we need, at what cost? The answer depends on how carefully we choose the path ahead.